Hello, good afternoon, and a very warm welcome everyone to day 11 of LDCE ADSTE preparation. And we were discussing 2009 LDCE paper from Western Railways. And today's topic is going to be question 2C and question 3A. We are going to see the solutions of these two questions from the question paper. And question 2C talks about essential requirements for double line lock and block instrument, and question 3A talks about transistor, its definition, configuration, and their respective circuit diagrams. So one of the questions, as you can see, is from signaling background. The other question is from the telecom background. And so let's see. So let's have a look on the question paper first and see if where exactly this question is. Question 2C, essential requirements of double line block instrument. So let's just open the question paper first. So here is the question paper, and question 2C, you can see it here. What are the essential requirements of double line lock and block instrument? In Hindi it's written like दोहरी लाइन ब्लॉक उपकरण के हेतु क्या क्या अनिवार्य आवश्यकताएं हैं, and it's for 5 marks. So let's see the solution of this question. If you want to check the detailed answer for this particular question, you can refer to ERESET note S22, block working, SL token and DL block instruments, page number 65, and you can get a detailed answer about this. I have taken a snapshot of what exactly is important from S22 and kept it in my slide. You can refer it in detail from the book as well, right? So what are the salient features of double line block instruments? So the salient features of double line block instruments are mentioned in specification number IRS S22-91, and you can see here the following components shall be provided within the block instrument. So what are the components that are required? The first is needle type visual indication, upper and lower, indicating train on line, line closed, line and line clear on segments colored red, white and green respectively. The second component required is a commutator. Third one is a bell plunger. Fourth one is a block bell. Fifth one is a HMT set with induction coil and condenser. And last but not the least, the three position polarized relay when required by the purchaser. Right? So if we have a look on the first component, it talks about needle type visual indication, right, which indicates whether the train is on line or whether it's a line closed or it's a line clear. And what are the respective colors of these three positions? Train on line would be indicated with a red color, and line closed with a white color, and line clear with a green color. Alright, you need a commutator as well, a bell plunger to exchange the relevant bell codes, a block bell, and a HMT set with induction coil and condenser, right? And the last one we have already talked about, it's a 3 position polarized relay when required by the purchaser. So these are the requirements, important requirements for a double line block instrument. The block handle shall be provided with electromechanical locking device with force dropping arrangement, which shall lock the handle after it is turned from line clear to train on line, right? So we should have a electromechanical locking device with force dropping arrangement which shall lock the handle once we turn the block handle from line clear to train on line, right? So that after we make it from line clear to train on line, we should not be able to move the block handle. Okay, so I hope this is clear and you all have noted down or taken a screenshot of of this of the answer of this particular question, the essential requirements for a double line lock and block instrument. Let's move ahead and go to question number 3A, right? So let's again open the question paper and see the question first. Question 3a is, what is transistor? Write its symbol. Draw circuit diagram for 3 basic configuration in which a transistor can be used. Which of these configurations is widely used? So a very basic fundamental electronics question. This question carries 10 marks, right? So let's just go to the slide and talk about it in detail. So the question asks you to define a transistor and asks you to tell the examiner about the configurations of a transistor and the circuit diagrams of these various configuration. If you want to have a look on this topic in detail, you can refer to T3 reset note, fundamental of electronics. To get a basic idea about the transistor, you can refer to chapter 4 of this reset note, which is about transistor operation. You can open page number 21 for this particular chapter. And the second topic which talks about the configuration and their circuit diagrams is mentioned in chapter 5, transistor current configurations, and you can find that on page number 25, right? So like always, I have taken the important part in my PowerPoint presentation. So actually the proper definition of a transistor is very difficult to find, but I have found a good definition from Wikipedia, and here I have quoted it, right? So Wikipedia defines transistor as, a transistor is a semiconductor device used to amplify or switch electronic signals and electrical power. So in this definition you can get clear with 2-3 things. First of all, a transistor is a semiconductor device, so it is based on elements like silicon, germanium, right? And it is used to amplify or switch electronic signals and electrical power. So what is the function of a transistor? The transistor can be used to amplify or switch electronic signals and electrical power. Now a transistor is composed of semiconductor material, usually with at least 3 terminals for connection to an external circuit. So as we all know, a transistor basically has 3 terminals, right? And that's why it is also known by the name triode for many purposes, right? And a voltage or current applied to one pair of the transistor's terminal controls the current through another pair of terminals. So below you can see the circuit symbol for a transistor, right? There are 3 terminals. The left terminal, as you can see, is emitter. Then you have the middle one is the base, and the right one is the collector. Now there are 2 configurations. One is NPN and the other one is PNP, right? So these are the 2 configuration of a transistor. So if you apply some voltage between the emitter and base, a voltage would be obtained at the base and collector, right? So that is what is the basic definition of a transistor. Now let's have a look on the configurations of a transistor. A transistor has 3 terminals: the emitter, the base and the collector. Using these 3 terminals, the transistor can be connected in a circuit with one terminal common to both input and output in a 3 possible different configurations, right? So when one terminal is common to both the input and output, on that basis we can classify the various configurations. For example, the first one is a common emitter configuration. So what is common here? Emitter is common to both input and output, right? And as you can see, the emitter terminal in this particular configuration is grounded. So you have to know 2 important things. Whenever a particular terminal is common to both input and output, that particular terminal would be grounded as well, right? So here in common emitter configuration, you can see that the emitter has been grounded. The emitter terminal of the transistor has been grounded, right? In common base configuration, base is common to both input as well as output, and the base terminal is also grounded. Now, and the last but not the least, in the common collector configuration, you can see that the collector has been connected to a reference voltage which is again grounded, right? And collector here is common to both input and output. So this is how the various configurations of the transistor have been defined. Now if you see in the first configuration, that is the common emitter configuration, you can see that where you can see V in is written. So input voltage, input AC voltage has been applied between base and emitter, right? And there is a input resistance Rin, which you can see, and there is a base current, there is a emitter current also, right? So if you only have a look on the input loop, you can see there are two currents, IB and IE. So the total current, if you talk about on the input side, would be IB plus IE, right? And similarly, when you have a look on the output side, you see that the output voltage has been taken between collector and emitter, and there is a load resistance RL, and there is a DC voltage applied at this side, at the output side VCE, on the input side it is VBE, right? Okay. Now the current here is, as you can see, is the collector current IC. Okay, so V out is the voltage at the output end, and as I told you that in V in we had got a voltage between base and emitter, and V out we had got a output voltage between the collector and emitter, and hence emitter is common between both these both the input and output. Now in the question, if you correctly remember, it was also asked which of these configuration is the most widely used configuration. So common emitter configuration is the most widely used configuration for a transistor. And why it is the most widely used configuration? Because in this particular configuration, the input voltage or the voltage is amplified, right? So whatever is the voltage that you apply on the input side, you would get a amplified version of it on the output side. That means if you see here, V in is the input voltage, V out would be some amplified version of this particular voltage, and that is only possible in the common emitter configuration of the transistor, and that's why it is also the most widely used configuration of the transistor. Talking about common base configuration, as I told you, base would be common for both input and output, right? And the base terminal would also be grounded. So as you can see, V in is applied between emitter and base, and V out you can see you are getting between the collector and base. So base is common between both emitter and the collector. That means base is common between both input and output. You can see that the resistance input is on the is connected to the emitter terminal, and RL, that is the load resistance, has been connected to the collector terminal. The same two voltages you can see here, VBE and VBC here, that is base emitter DC voltage is between on the input side, and base collector voltage on the output side. So that is about the common base configuration. Now talking about the last configuration, which is also a very important configuration and is also used in the industry, is the common collector configuration. So in this particular configuration, collector is grounded, but it is connected to a reference voltage also. So collector is grounded through a reference voltage in this particular configuration, right? Perfect. And in this particular sort of circuit, you can see that the input voltage has been directly applied to the base of the transistor, right? And the output voltage you are getting at the emitter, right? The output voltage you are getting at the emitter, and you can also find the load resistance RL connected to the emitter directly. So you are getting V out at the resistance which is connected to the emitter, and you are getting V input at the base on a resistance connected to the base, that is Rin, right? And this type of circuit is called the voltage follower or the emitter follower circuit as well. because as you can see, the voltage, output voltage that you get is actually the voltage at the emitter, right? And that's why it is called the emitter follower. This type of circuit, that is the common collector configuration, is used for impedance matching circuit as well in the industry, right? So we have answered both the parts of this particular question. We have defined transistor and also given the configurations of a transistor with their circuit diagrams, right? And we have also mentioned the most widely used configuration out of these three configurations is the common emitter configuration, right? So I hope this is clear and you all enjoyed this lesson and found this really useful for your preparation of LDCE ADSTE. Now, talking about the slide that you see on the screen, this is a very memorable moment for me in my e-research journey. So I secured first rank in my batch. As you can see, this was the initial course for apprentice JE in the certificate course number ISP 0120. So a very special moment when I received the academic award as well as the S.H. Srinivasan award from the honorable members, and so I thought of sharing it on the very last slide. I hope this adds some value to your preparation. This is Prashant Goklani, Junior Engineer Signals, signing off. Have a great day.